het woord geven. Okay, I'm switching to English now because I'm very glad that we can welcome here Andreas Blumauer for, in my view, very interesting talk. Some facts about Andreas. Andreas has a master's degree in business informatics. He is the founder of the Semantic web company already more than 15 years ago. And he is mostly known in the Netherlands, I think, from his pool party software, which applies text analytics for automatic tagging, among others. But now he is very enthusiastic about knowledge graphs. He also published a book about it, and he will make the connection with between knowledge graphs and automatic tagging in his talk. But I'll stop with it, and I'll leave the floor to Andreas to introduce himself a little bit further and to present his talk. Andreas, the floor is yours.
Yeah, thank you very much, Eric. Thanks for the invitation that I'm able to give a talk here in this great round of people. And yeah, I will talk about knowledge graphs and how this is related to text mining, and not just technically, but also what you can do with that, why you should pay attention to this approach, and yeah, give you also an idea how you can make that work also in your own environment. And so I think we're all set. Can you see my screen, the slides? Is that the case? You see my mouse moving around and all that? Just give me a hand. Okay, thank you.
Yes, that's cool. Fine, like this.
Okay, super. Thank you. So yeah, I will introduce myself just quickly using a bit of a knowledge graph. As Eric already said, I'm somewhere in between computer science and business, and was always keen my whole life to bring things together, make any kind of information and data useful for the people working on complex scenarios. So we got really quickly fascinated 20 years ago about the semantic web. We thought, okay, this is really now coming to a point where the internet makes sense. We all know that the semantic web itself probably has not developed in the direction we initially thought. The web looks a little bit different than Tim Berners-Lee's vision was probably, but all the great stuff which was developed in this area then got more and more adopted by many different organizations, large enterprises, NGOs, libraries. So earlier a huge community was fascinated about semantic web as well. And in the meantime, we all know it's discussed under the topic of knowledge graphs. So we've seen some naming conventions in between. For a while, it was called linked data. But I think what's really new in this knowledge graph discussion now is it's not just the technology itself, which is discussed, but really also the governance model, the way how you can embed it in an organization, how the change management should be made to really make it happen inside an organization, which probably is already used to other ways to deal with data, like data silos, waterfall methods, and all that. You know, we're all used to that in large enterprises. And the knowledge graph approach is a little bit different. It's more about the collaboration between different stakeholders. It's quite an agile approach to deal with data. It's no longer about data silos. We really try to bring together structured and unstructured data. So yeah, it's a new way to bring data probably to the next level. And it's not just about data, it's very much about people. So our claim at Semantic Web Company is linking data to knowledge. So we believe if data is put in the right context, in the right process, used by the right people, then there's a big probability to make some useful knowledge out of that data. So yeah, this is our approach, and by that we were starting out in 2009 to bring a product to the market. Some of you may know that's the Pool Party Semantic Suite built on the Semantic Web Standards. and it does a couple of things for enterprises and NGOs and other organizations. It most of all helps to build out knowledge graphs, being composed into several, let's say, pieces down to the taxonomies and ontologies. And then as a result, text mining is one of the features which then can be used on top of that platform. And what just recently also was making me busy was I was writing a little book about knowledge graphs, how they can be made possible in an organization. It's the Knowledge Graph Cookbook. So if you're interested in reading the whole story, so to speak, then please take a look at it. You can download it for free as a PDF, or you can also purchase it on Amazon as a hard copy, a paperback book or a Kindle. Okay, so that was a quick introduction, but today I'll talk about, so how is text mining related to knowledge graphs? And we call that deep text analytics, and I would like to introduce you to this concept, how different methodologies come together to make text mining really powerful for different use case scenarios. So also bringing that in a bigger vision and in a bigger context, why is that important? What we've seen in the past 10 years or so was quite a lot of machine learning and great applications based on that. Deep learning was obviously very successful with a lot of different tasks to classify data, to do some great stuff with data in general. But one of the pitfalls here we've seen was, first of all, it's not necessarily explainable. So we go more and more in a direction of establishing AI infrastructures, providing explainable AI. And the other pitfall somehow is that at any time you start out with a new machine learning project, you somehow have to reinvent the wheel. So there's no such a thing like a data infrastructure where you can take data out and reuse it again and again. We all know that data preparation, data quality activities are quite time consuming. So we also see the knowledge graph as a great way to access data, to make it accessible, to make it make data well available based on the FAIR principles, which means findability, accessibility, reusability, and interoperability. And we believe this is all possible with a knowledge graph based on semantic web standards. And the exciting part here, and we will come to that quickly, is the interaction between machine learning and knowledge graphs. So we will see that also with deep text analytics. Here we can see obviously that text mining works more efficiently, more precisely when using knowledge graphs in the background on the one side. And on the other side, machine learning algorithms can help us to expand on the existing knowledge graph, to semi-automatically enrich knowledge graphs, to run by inferencing mechanisms, for instance, certain algorithms to extend the fact base and all that. So this is where machine learning and knowledge graphs can work together very nicely. I think in a couple of years, we see more and more of self-learning mechanisms in that case. But still, we are strong believers that there should be a human in the loop. So there's a human in the loop design principle, the HITL principle, which makes on the one hand, the AI explainable, the text mining explainable. And on the other side, of course, we see ways how subject matter experts still can bring in their knowledge into the infrastructure, and this is key. I guess we won't have AI in place in the next 20 or 30 years or so, which work completely independently from human beings. So this is not the case, at least not in sophisticated industries and enterprises where, you know, a lot of noise has to be analyzed and a lot of sense making and reasoning has to take place to make good decisions again and again. And yeah, that also is one part of the text mining we go towards too. We also want to more and more make question answering machines possible, not just a typical search engines, we all know, where you ask or put in a keyword and then you get a bunch of documents. This is great. I mean, semantic search is a low-hanging fruit to use knowledge graphs for, but more and more of our clients and all the projects we see currently is that people are asking questions and then they would like to get answers and not documents, and or at least they would like to get pointed to the right snippet of the text within a lengthy document. So that's also one of the reasons we have to improve typical text mining facilities. And since we're talking about knowledge graphs, I think it's about time also to take a closer look to what it is. There's many knowledge graph flavors now around, since it really took up as a very interesting methodology. Gartner and all the other big analysts are now really very focused on explaining knowledge graphs as a core element of an infrastructure, of a data management infrastructure. So obviously it became really popular in the past 3 or 4 years now. So we should be a bit cautious of what a knowledge graph really is. I mean, I'm not coming up with the only possible definition now, but at least some element should be within a graph to be able to call it knowledge graph. And one typically really is, it's not just an ontology, for instance. That's a common misunderstanding, or the other way around. It's not just transforming a relational database into some graph structure. It's a combination of that. So it typically consists of a conceptual and linguistic model. So there could be an ontology or a taxonomy or both of that, or many of those. Typically we see sets of taxonomies, ontologies playing together in such an infrastructure. And then it's partly, let's say, virtual graph on top of existing data sources. And the data sources then are typically transformed into a graph structure with help from the taxonomies and ontologies. And that is something, of course, you can do nicely with any unstructured, semi-structured, and rather structured data objects. So when today we are talking more about text mining, then typically, of course, we think about Word documents and PDFs, but don't forget about all the unstructured elements in a typical relational environment, like an Oracle database. You will see a lot of elements being unstructured, and still you would like to make sense of that and transform it, if possible, into something more structured. And this is exactly where ontologies and taxonomies can help you with, because this is the foundational element to extract entities and translate any term, any string into a thing. So this is really one of the core principles of semantic web technologies, that we no longer talk about strings or names or labels only, but also, and most of all, anything in your company, in your organization, any business object, any topic, any idea, probably any process, whatever you will find and you make sense of, typically will be translated into a node in your knowledge graph. And that can be partially done automatically. So this is this part of the infrastructure that's typically generated automatically by means of text mining or RDF, transformation steps, validation steps, reasoning steps, and all that. But typically a knowledge graph would never ever reach a certain level of quality if you do not spend enough time on the taxonomies and ontologies. So they are really a prerequisite to create a really well-shaped enterprise knowledge graph, which is sustainable, where you can add and more data sources over time, and where you really translate the actual business users' needs and data scientists' needs into the existing database. So this is also, of course, an interface to make the data then available to several applications. We could call them semantic AI applications. And those applications now no longer have their own business semantics contained within the application layer, but in contrast, they really take the semantic layer, the conceptual and linguistic model of your data as part of the interface to access the databases. It's really a nice, I would say, architecture which no longer has let's say, the disadvantage that you continuously repeat yourself when developing a new application with creating data sets you have already created somewhere else. So it's also an infrastructure. An enterprise knowledge graph is an infrastructure. Think about, for instance, a geographical graph where you will find all the regions and districts of a country. No longer you have to maintain that separately for each of the applications which are in need of such a data. You really provide it as a service. So the enterprise knowledge graph should be accessible through service endpoints. And of course, a good idea is to use therefore standards like Sparkle or GraphQL, of course, is now also a very important standard interface to access such data structures, or just a RESTful API, probably, where your developers can quickly understand how to access data from the enterprise knowledge graph and mesh it with other data sources. So this is kind of the approach we propose here. And so parts of the data, of course, there's not such a big need to have text analytics in place because it's already to a certain degree structured. So it's more translation between tables, spreadsheets, relational data models into an RDF representation by using ontologies. But as I've said before, lots of the data, parts of the data you have in your organization are typically unstructured. And here we need deep text analytics. So what is it? What is this text analytics I'm talking about? Of course, I will come up with already quite a sophisticated problem here. Of course, one of the first steps, and I will come to that afterwards already, is just to detect and identify important entities within a text. So this is always the basis. But how can you then, with that information, really figure out what a text is all about? So it's really rather sense extraction, what you need to do to understand, okay, where are the pieces of your collections of texts and documents which can fulfill certain intents, information needs on the user side. So what you see here as a human being, when you read through such a text, you are quite able, of course, to make sense of the data. You put several senses around fragments of text. Think about a technical documentation or a description of a region, like in that case. Okay, what part of the text is talking about a how-to guide when you want to install a software? Is it this or is it that part of this help page? Or which part of the journey description is talking about the fact that a certain region is great for wine tasting? So is it this or is it that? So obviously it's not just by extracting one single word that you can already guess what the text is all about. You really need to have a bigger context. You need to understand relations and things, how they are related in a certain text, which facts, which attributes and all that can be found in a certain text. So it's, as you could call it, aboutness of a text. And one of the elementary, let's say, components of such an, to solve such a problem is, first of all, that you can extract entities. So one typical approach, therefore, is the so-called named entity recognition approach. I show you a little demo example firsthand. So that's just a quick demo. Some text, some sample text you can pick here from. It's in the area of medical information. And here you have a named entity recognizer. And so here, and that's quite interesting, typically you get some pre-built named entity recognition services on the web, like Amazon or Azure, and all the big tech companies provide that as a commodity in the meantime. And they are pre-calculated, pre-built. Typically, you can extract persons and locations and all that. So no need to run a knowledge graph, really. But when it's getting really interesting, then later on is, of course, in your business or in your type of activity, you typically have very specific entity types. Like, for instance, in the medical field, you may be interested to be able to extract diseases from a certain text. So how can that be trained? Because this is based on a typical machine learning algorithms which get trained. You need to have some labeled documents, and by that the system can learn what a disease is. So, okay, in that case, what we did actually was we trained the algorithm by using a knowledge graph. In that case, it's based on MESH, the medical subject headings, a huge taxonomy, which is used frequently for such purposes. So we trained by using MESH the algorithm. That means we pre-labeled a set of documents so that can be found here. So those are the concepts which are found in here, and those concepts are really derived from MESH. So this is a core functionality of Cool Party. And by that, we get a lot of pre-labeled documents which can then be used to train a named entity recognition algorithm. And then you may get even more of diseases out of the text which were not in MESH, in that case, initially embedded. So this is also quite a nice mechanism. So you use the knowledge graph, you use a taxonomy, which is part of a knowledge graph, to train such an algorithm, and then you can use the extracted values which you get automatically and push them back into your knowledge model. And I can show you that also within our software. So here we have a little example of a taxonomy, which we also use internally. So it's the Semantic Web Company Enterprise Knowledge Graph. And what you can do here, I mean, that's of course a clear feature. I have to, I'm logged out already. So what you have here, of course, is ability to create and expand on taxonomies. You can do linked data harvesting and all that. So linked data harvesting means you can make use, for instance, of DPpedia, of Wikidata and all that. And what you can do here is you can start out with creating topics and concepts and alternative labels and all that. And that's then used for text mining. Yeah, you can extract from any given text, of course, then the corresponding parts of the text. But what you can also do here is you can try to find, based on the text corpus, more of terms you may include in your knowledge graph. So, for instance, what I've got here are chapters of the knowledge graph cookbook. And what you see here is what are the most frequently used terms and concepts in the knowledge graph cookbook. So it's, for instance, a knowledge graph, what a surprise. And then the second most frequently found is artificial intelligence, by using the label AI, which is a synonym. So that's fine. So you see here already text mining also helps you to understand, as a knowledge graph manager, as a taxonomist, how to expand, how to elaborate your knowledge graph further. And in return, also text mining will help you to find or identify gaps between what you have and what in the text is found. And it starts to come up with suggestions, like it may say, okay, search would be interesting, or visualization would be interesting. You can also blacklist it here. And by, in that case, double clicking on it, you get it into your candidate concepts area, and you can look up kind of co-occurrences between what concepts are typically found together with search in that case. So, for instance, Microsoft, Google, Cool Party Graph search engine. So those are, let's say, co-occurring concepts to this search term. And then there are also other terms which are not yet in the knowledge graph. And And by that, you can start to expand your knowledge graph step by step. In that case, quite quickly, if you do drag and drop, you can put there that as an alternative label and all that. You can use that as a broader concept to bring it into the hierarchy and all that. So here text mining is helping to create the knowledge graph further, and then the more complete the knowledge graph is, the better the text mining gets. So this is one of the core mechanisms you find here. And coming back to this idea of having an aboutness, a way to do not only entity extraction like we've done here, as simply spoken, but a more sophisticated one. How does that work? Obviously, you need to define a kind of graphs, bigger graphs, like shapes of graphs. What is typically found in a certain text that you can assume it's about a wine tasting journey. Yeah, what's found in there, and this aboutness is something which is then important for use cases, like for instance for contract intelligence. Yeah, if you really want to determine which of the clauses are the ones where you should be very cautious as a legal person when you get a new contract proposed by a vendor, for instance. So this is something where this already is then applied, the aboutness. Or another way to use that approach is also for recommender systems. A recommender system, we see that frequently. I mean, there's collaborative filtering, which has nothing to do with text mining, really, like we all know from big web stores, where you just look up, okay, this person bought the same, like a bunch of people who then also bought something else, then the single person then also gets that proposed. So that's collaborative filtering. It works nicely if you have a really huge customer and user base. But when we want to build out the recommender system, which for instance brings together things, people, for instance, documents, yeah, a recommender system which really understands the aboutness of the skill set of a person, the content of a document, then it's a good idea to have something like a semantic footprint on top of this knowledge object. And the semantic footprint is nothing else than a little snippet of the entire enterprise knowledge graph. So it's like, just imagine any one of us, yeah, here in the virtual room, if we were able to understand who is interested in what, who knows what, we could quite quickly come together in little outbreak sessions and start discussing it more specifically. So I don't know who of you, for instance, is interested, I don't know, in SharePoint or in technical documentation or in legal text and whatever. So there's many different variations how to bring knowledge objects together precisely. But of course, as a prerequisite to do so, you need to have a rich context model around all these different knowledge objects, and that's what we call semantic footprint. And the semantic footprint is something which typically is more than just a bunch of tags. Yeah, it's like here you could assume, well, this is just a bunch of tags, and again here and here, what do you extract here? So literally spoken, nothing has anything to do with each other. So you wouldn't find any matches between the tags. But of course, when you embed that into a larger context model, a knowledge graph, then all of a sudden things come together. They are related with each other semantically based on the aboutness of what they are actually talking about. And then, of course, it would be great if you have segmented your documents into smaller chunks, like in the technical documentation or in a description of a journey. I said that already. And then you can really bring only the snippets of a lengthy document to the table where that person probably is interested in, or where an image fits into a certain text component. For instance, think about knowledge creation, very cost intensive. If you had recommender systems like that in place, you can much quicker find assets to reuse them again and again in different, let's say, distribution channels. So this is not only interesting for the end user, but also for the content producer, and then most of all, also for enterprises when they would like to build out a knowledge management system. Yeah, and I'll give you an example for that, which is you can also try it out live on the web if you like. So this is what we call the HR recommender. So it's a snippet of a system. Or of an approach of a design pattern we've seen frequently within our customer base. So our customers are looking for ways to use such graphs to do recommendation services which bring knowledge assets together. So here, as an example, it's a pictures company with employees. A couple of employees are exposed here to play around with, and I take Evert van der Laar as an example, a knowledge engineer in this company. And what you see instantly when being logged in is, so those are those colleagues Evert should talk to, yeah, because of matchmaking, semantic matchmaking between the different footprints, where the system understands what kind of skills and interests they have in common. Behind the scenery, by the way, there is a quite extensive knowledge model in use, which is the European Skills, Competency and Occupation Thesaurus, ESCO, huge project by the EU since years and frequently used in this HR area now. And of course, it's sometimes not specific enough, yeah. Such a pre-built taxonomy. So therefore, again, you would need, as I've shown you before, this corpus analysis where you feed in your specific, for instance, resumes you got from applicants. And by that, you can enrich the pre-built ESCO with more specific concepts, relations, synonyms, and other information, metadata around the concepts, which you derive from your own specific text. And that's what we did here, because it's more about IT related people and projects. And as a result, you get such recommendations automatically. So what you see here, those links between the objects, so those are, for instance, projects and their descriptions. And here we get open positions if you want to recruit internally of a large enterprise. That's typically what you would need. Then you get this as a result. And what's also quite interesting and nice, I would say, is you could now start to search over the whole company colleagues, the base of what are the potential contact persons when you fire up a new project, for instance. So who has a specific knowledge in a certain area? You can also rearrange that by putting weights on it. So you could say, well, this is my knowledge profile. Yeah. So I'm good with OWL, with Sparkle, with COS and all that. But I could say, well, I'm really more interested in Sparkle. This is really important. And what you've seen down here, now it got reordered to a certain degree. So you can also become very specific about the semantic footprint you would like to apply to detect the right knowledge assets. And you also see here, for instance, this guy is a taxonomist. He's good with taxonomy management. And Evert, my account, he's not. So, but the system, of course, was able to put that into relation to what Evert is interested in. He's interested in knowledge engineering, which is probably a broader concept of taxonomy management. So, and by these indirect relations, obviously also the matchmaking works much better and the recommender gets more precisely. Again, it's really about detecting the aboutness and not just the literally exposed term-based description of the knowledge assets. Okay, so this is another very important use case for this approach. And then, of course, the classification text in general. So this is a very frequently found use case. You would like to, and that goes really not only about the whole document, but snippets. And it's not just single classes probably, or just a linear bunch of classes rigidly described upfront, like I want to classify my inbound emails into this is important and this is not important. This is something you probably don't need a knowledge graph for, so this can be really trained differently. But when it comes to, we have certain intents in our company, maybe also not millions of them, but rather thousands, but differently formulated. This is typically what a question answering machine has to resolve the problem of, let's say, variations of how to express an intent, whereas the number of intents are quite relatively small. Yeah, that's what we typically see, for instance, on a technical help desk. So what you need to do here really is to classify content with regards to assign them to certain user intents. And again, it's something which is quite tricky, because obviously it's not just a simple matchmaking which works. You need to know a lot of stuff in the background. So for instance, in that case, you need to understand that a US-based private equity firm is only then US-based if this firm has its headquarters in a city which is in the US. Yeah. And so therefore you obviously need, for instance, a geographical knowledge model. You need to understand that Boston, Massachusetts is part of the United States. And this is typically what you can bring in with a knowledge graph infrastructure. You can find those missing pieces to infer that this intent has something to do with this text segment. So you've seen there's a lot of different ways to do text mining. We've seen the simple named entity recognition. We've talked briefly about the graph-based annotation. There is also ways to use large corpora, to run word embeddings, for instance, to do co-occurrence analysis. We also, that's probably nothing we've talked yet about, we extract shadow concepts. That's also quite an interesting approach, I'd say, which is able to extract concepts of a given text, even if they're not there, but indirectly mentioned to a certain degree, because many other concepts have been extracted, which typically occur together with this shadow concept. So if I would now say, today here in Vienna, it's a sunny day and it has 23 degrees. You could assume maybe that a shadow concept is, I don't know, swimming, ice cream, and summer. So that's something which can be learned from large text corpora automatically. And the shadow concepts extraction, of course, is something which is then later on quite useful when, again, you want to determine the aboutness of a text. Yeah, and ontologies play also a very important role, of course, because you really can classify found entities. You can then also say in certain given application scenarios, you only want to extract concepts of certain types. You're not interested in diseases if you talk about journey reports, because this is not important in this context and all that. And the document classification is another metadata you can produce nicely based on knowledge graphs, not only, but also which typically work based on algorithms like SVM or naive-Bayes logistic regression. So you train your classifiers by pre-classifying a training set. And again, here the knowledge graph can help to enrich the training data with additional semantics, and by that you get a richer input to your machine learning algorithms. And it's well proven that you can then benefit from less training data, and more quickly the training or the algorithm gets trained. And in enterprise scenarios, we frequently see that our clients do not have enough data to train their algorithms that efficiently. So it's always good to have some ways to enrich that and make it more structured. And then good old regular expression, of course, also is very important to find elements in the text. And putting that all together, you create kind of a digital twin. Now people start to say of your document. You can create a semantic footprint, some say. In essence, it's always, let's say, a sub-graph of the entire knowledge graph, which then represents your text. And then you can come up with, for instance, a rules engine. You could use, for instance, Shackle, if you're familiar with that. That's a standard, again, of W3C, to determine, okay, which of the text segments fulfill certain criteria or not. And by that, you can filter out, for instance, from a contract, certain segments. I'll show you an example how that can then work in reality. Again, a little demo on the web. It's called Contract Intelligence. We've got a bunch of publicly available contracts. And the idea is, okay, how can we now determine in which of the contracts we find clauses, certain types of clauses, which violate certain quite complex rules. Yeah, like for instance, certain types of actors or parties are mentioned together with certain keywords, and maybe a country, a region which fulfills a criteria like outside of the European Union and all that. So if they come together in a certain combination in a certain clause, then the ring bells of lawyers typically, and they say, oh, this is something we should be cautious about. Let's talk about that in more detail. And if you have a really large number of documents, you have to analyze like that. And it's good to have a machine which can at least help you to prepare, let's say, or mark up already certain segments automatically. So let me show you that. Let's say I'm looking now for insurance clause, and I take just the first one, for instance. What we see here, that's a very simple one because it's based on a simple word. That's the insurance clause number 2, and that's now marked up. So this is a simple one. Let's go to a more complex one, for instance, termination. Here, let me see, maybe I go to another one where it's getting more interesting, or confidentiality probably may produce like the SAP contract, maybe. The confidentiality here, what you see, for instance, is the rule is talking about when a party then the activity not communicate and confidential information comes together in a given context, then this rule should be applied. What we find here, for instance, is contractor as a sub-concept of party. You can model that in the knowledge graph. And then, of course, in the same knowledge graph, you can also come up with synonyms. You can come up with types of parties in that case. And all that helps, of course, also to decompose to a certain degree the problem, because the knowledge model itself can quite quickly be modeled by someone who is probably not even a lawyer, because what types of parties typically occur in a contract is not necessarily a secret knowledge. What's more interesting is then, of course, so what are typically the things which have to come together to apply a more complex rule? That's probably goes beyond someone who is not a professional. So you really need to include here maybe a lawyer, but you can decompose the problem really into formulating the rules on the one side and modeling the basic knowledge of how contracts are set up on the other side. And that's what actually also happened, because this graph was not created by a lawyer. We did that, and one of our employees who is kind of a lawyer was doing that in that case. That's quite straightforward to do so. But the nice thing is it's a combinatoric problem you can solve by that, because there's so many ways, yeah, to make the aboutness explicit, to describe the problem, and you would not like to, write all these or clauses in a Java program. anymore, because this is really hard to get maintained. It's not explicitly shown by that. So it's a better idea to use a knowledge graph really to model that first in an environment like this one I've just shown you. So this is something you can take a look at, and you don't need to include a Java programmer or a data scientist for that. So yeah, this is one example. So to sum it up, it's a bit of a fusion approach. We've used different abilities. We include language modeling capabilities. We use a corpus typically in corpus linguistics to enrich the knowledge graphs semi-automatically. We run machine learning algorithms, especially for the classifier, because you need to segment text typically. You cannot just use the whole document. You need first to segment them, especially contracts, into smaller chunks, or technical documentation as well. You could use there maybe the data information that's a standard to structure technical documentation, but not in all the cases we have well-structured text typically. So sometimes you need to bring up machine learning algorithms to structure the text upfront. And then, of course, you can fill in a lot of, let's say, background knowledge by using, for instance, semantic web sources like Wikidata, DPpedia, GeoNames, and then more industry-specific graphs, like in the pharmaceutical industry, and enrich your knowledge model by that. So we believe that this approach can help in many cases. You've seen recommender systems, you've seen contract intelligence. I've shown you also quickly recommender systems. So maybe also let's take a look on question answering. So question answering is probably also an interesting area where knowledge graphs and text mining together then can produce something meaningful. Question answering, I show you an example. So this is based on a cooperation we have with a French company, QAnswer. And QAnswer is a technology provider using knowledge graphs as a basis. I mean, the question how to come to a knowledge graph can really, there's lots of ways to produce that. But as soon as they have the knowledge graph, then their system starts to learn which Sparkle query, that's the standard language for knowledge graphs, which Sparkle query gives an answer to which natural language question. So this is a quite interesting approach, I would say. Yeah, the creation of knowledge graphs in that case depends on the use case. In that case, what we did as an example is transforming a Git repository into a knowledge graph, where you find hundreds of projects and contributors and licenses and bugs and whatsoever. This is again something where you would do a combination of data transformation, entity extraction, entity linking, and all that. Of course, the quality of the knowledge graph is key to make a question answering machine like that really happen and powerful. And okay, so what happens here? So I can have a list of a little list of questions, so which you can ask already. So you see here quite a lot of types of questions we can ask. So I will start, give me all repositories, for instance. So that's the first question type. And then you see here already, you can give feedback if that's the right answer or not. So I believe that's okay. And those are the potential Sparkle queries, which were calculated based on the natural language question, which may produce a result. And then, of course, the secret sauce is to learn from the feedback of the user quickly enough to come up with the right Sparkle query. And in the knowledge graph, you can also, of course, inject different formulations and synonyms and all that, so that the natural language based question can be translated into the right Sparkle query. So it's an interplay between those different things. So let me ask another question then. For instance, what is the programming or of? So I need another repository then. Question, TensorFlow. Okay, what is the programming? Oops. No answer. It's a great example. Sorry for that. And I'll try another one. Okay. So this is obviously not the right answer. No. And then basically, and the confidence is quite small, you train the system then by that step by step. So obviously this type of question is not well enough trained yet. Maybe it's rather down here what would be the right answer. This doesn't produce any. So this is the approach. You see, of course, the question answering problem is probably the most trickiest one still. That's where we're aiming for to start out soon, yeah, to be able to produce Q-answer interfaces on top of any data, really. It could be semi-structured, unstructured, structured, and all together. Typically an integration of different data sources, of course. And this is, so to speak, the holy grail. Yeah. Okay, so this is, I would say, the most important, those are the most important messages I wanted to bring over with a couple of examples. In the slide deck, you find, of course, more in-depth information than of what I've been talking about. But I don't know, Eric, do we want to have a little question answering session at the end now, or how about timing, or should I just continue till 3? What would you prefer?
Yes, I was wondering how much stuff you still had to cover. I like some questions to be possible to ask you at the end.
Mm-hmm.
So please go ahead a little further, but not much after, say.
Okay.
Till about 3 o'clock. 5 minutes after 3, and then I'd like to start some discussion.
Okay, yeah, fine.
Yeah, is that fine with you? Well, I'm not on the minute to that.
No worries. So how much time do we have till 3:30, or what was the
plan? some 10 more minutes, is that okay?
Yeah, absolutely.
With you?
Yeah. Okay.
Okay.
So yeah, what's probably also a bit helpful for, let's say, those who are not so deep into such linguistic models, you know, with COS, that's a great way to build out such a linguistic base to describe a knowledge domain. And this is a little example where you see also in one place what the difference is really between synonyms, frequently messed up with homonyms and homography in general. This is really something else, but in both cases, it's important to model that somehow and make the machine able to understand, okay, in that case, there may be a trap. It could be ambiguous if you find something like Jaguar. And also when you do, for instance, as I've shown before, recommendation systems or simply spoken search, then the system, of course, should know that the Jaguar is the same as the Panthera onca. Depends if you're a zoologist or not, probably. If which words you're going to use in the medical space, that's very important. So I believe this is key, of course. So that's a prerequisite, really, to have more accurate text mining. And then again, if it's more complex, we all know that the world is not hierarchical, it's polyhierarchical. So anything can be put into any context, potentially. I mean, sometimes that doesn't make sense, but there are many ways to interpret a thing. So it's of course a different story if you say the Jaguar is a keystone species. That's interesting, and probably in different contexts to understand what a keystone species is, what consequences it has, and so on. But of course, you could say simply a spoken Jaguar is of type elite. Yeah, that's something else. That's a different context than you give with this hierarchy. But in any case, those are the three big, let's say, things you should know when starting out with a simple knowledge organization system, that you can cover already those types of, let's say, linguistic problems, if you want so. And the other basic idea, once again, why you should take attention or pay attention to knowledge graphs really is that in most of the, let's say, search engine problems you want to solve or analytics problems and so on, typically your data set you have at your disposal may be great for a specific problem and cover also the facts and all that for this specific problem. But it always assumes that at the end, when the interpretation takes place, the user adds some more context to the results, which is you could also call background knowledge. As a doctor, yeah, you have a lot of background knowledge when you see a result, and then you can make sense of that. But in many cases, it also makes sense if you establish this background knowledge as a service where your data set can be attached to quite quickly, and when you use standards, that's something which is not as cost efficient or cost intensive anymore. And in that case, for instance, you see a little example. You have maybe a question like that. So which cities located in the Commonwealth of Nations have a population of more than 2 million people? And then only with that, those two documents, the machine at least could not give any answer. But as a human being, most of us would know Australia, yes, that's part of the Commonwealth of Nations. So by that birth, obviously, is a valid answer to the question. But if you don't have this fact that Australia is part of Commonwealth of Nations in place, then or that birth is part of Australia, also that's not clear by the facts given, then you need to add a lot of your own knowledge into the mix, yeah, to give an answer based. So it's really a fragmented situation again and again. And why not using large knowledge graphs in addition to the enterprise data sets you have, and really mix them together, and by that providing interfaces to, let's say, your support desk engineer, support engineers, yeah, improve a support desk. That's a typical situation. We always assume that the support engineers knows a lot of things about the products, but sometimes that's not the case. Think about turnover rates. So if the support engineers always have to get trained about everything, it's probably a better idea to add that kind of background knowledge to a knowledge base about the product and then mix it into the technical documentation as an example. And even the knowledge graph can help to avoid really illogical answers, like by using ontologies and stuff like that. I mean, this is really a real example when you use, you can probably predict what it is by the design. It's very Google-like. And it's really the result, if you ask a question like that, how far am I away from Perth, Australia? The system gives you an answer like that. Distance between Perth and Australia is 1,200 miles. Doesn't make sense, of course. So yeah, I'll skip that. And probably that's the last slide then I'd like to come up with. That's also a bit of a summarization of deep text analytics. Obviously, it's about extraction of the non-obvious, what we need to bring in place when we want to make better use of text mining. So the first mechanism here is about entity extraction based on concepts instead of simple term-based extraction. That's the first step. So we no longer just extract coffee and table and computer as literals, as strings. We really extract them as things to get a URI. By that, we look up in a knowledge graph and see, a computer is a device which needs electricity. So later on, you can ask questions like, which of the things I have in my room need electricity, even if it's not in the text written. So that's one of the things. Also for the sake of having better ways to disambiguate and all that, it's very important to have entity extraction based on concepts and no longer just based on strings. That's the first step. Then the second one is what we want to make use of is to have more ways and more ability to exploit the context around the things. We want to extract them, for instance, superclasses, broader concepts. So no longer everything has to be literally put into the, for instance, search engine. I don't have to ask things like show me all documents about cats. Yeah, even if it's not talk about cats, but only Jaguar, we still will get the document then. And the knowledge that the Jaguar is a cat is something we typically then inject while using a knowledge graph. Then the next thing, of course, is some other types of relations. They get more and more specific when you use ontologies. Pure statistical approaches somehow can determine, yes, A has something to do with B, but what exactly it is, we don't know. Some can predict it's a synonym, some can say it's a hierarchy, but that's typically it. So extracting facts from text is quite tricky, and determining the exact relation between the different things found in a text automatically is also tricky. But what we see currently is with a knowledge graph in place, again, you can also train fact extraction algorithms more accurately. Then I talked briefly about shadow concepts. That's another additional signal you can mix into your machine learning algorithms and your applications. So the shadow concept extraction means you can extract things which are not really mentioned in the text, still by the co-occurrence of a larger text corpus, you can infer that this is also indirectly mentioned. You can use a classifier to classify whole documents or snippets of them. And last but not least, if you put that together and then really determine, okay, the aboutness of a text by using a graph language like Shackle, then that's what we call deep text analytics. And that opens up a wide array of new use cases by that. So yeah, that's it. I hope it was somehow useful, that you had probably a bit of an idea of what with text analytics based on graphs can be done. What I'd love to learn from you, if possible, if you had 1, 2, 3 ideas of how to use that approach, or also, of course, technical questions are interesting. I'd love to stay with you in the room for another 10, 15 minutes, whatever you like. Thank you for your time and for your attention. Hope you enjoyed.
Thank you very much, Andreas. You covered a lot of topics, so I guess there will be some questions, although I did not see, let me look, no real questions in the chat yet, but I see some raised hands. I saw a raised hand by Annelies van Nispen. Annelies, can you unmute and ask your question?
Yes, well, thank you for your super interesting talk, and I would love to read the book, so maybe you can also, you can download it, the PDF somewhere, you said, so maybe you can post a link. But my question is about Pool Party, because you were text mining in Pool Party with, if I understood that correctly, because we at NIOD use Pool Party for our World War II thesaurus, but we can also use it to upload corpora in or create corpora in Pool Party and then run. Yeah. Okay.
No, absolutely. This, I mean, most of the users working in the field are kind of aware that the Pool Party Semantic Suite can help to create knowledge graphs, taxonomies, ontologies, and then some more advanced users also use the text mining facilities of Pool Party, as shown just before. So starting out really with term extraction, concept extraction, shadow concepts, deep text analytics, finally, plus the ability of using a text corpus. So you really upload a bunch of documents into the system, and then it helps you to determine, okay, where are the gaps, which terms should be included in which position of the existing thesaurus. And also in the background, the model is then later on be used for text mining. So it's not just thrown away. it gives you kind of a bigger graph around the manually created graph. So it's kind of the handcrafted part of the knowledge graph is embedded in a bigger graph by that, and the whole is used for text mining and text analytics later on, and that's part of the enterprise server and higher.
Okay, that's super interesting. I didn't know that, so thank you.
Okay, of course, yeah. I see Will Restenburg was asking a question. Do you expect these techniques can be applied on video? So not only text analysis, but also other kind of information and data analytics and so on. Yeah, of course. I mean, it's always important to have some text in place to do so, but a video can be translated into text, speech to text, video to text. There are many of such services around in the meantime, which work really greatly with good efficiency for different languages. By the way, the text mining we talking about works not only in English, of course, but also in Dutch and German and French and so on. And if you had a kind of a transcript of the video, which, for instance, YouTube is producing it automatically in the background, and you feed that into your text mining engine like Pool Party, you could do the very same then as I've shown you with pure text. That's possible. And if I understood correctly, but also other kind of information, data analytics, you're asking, if I understood correctly, I mean, what typically I have in mind always is there's content and text, and on the other side, there's data. And when people say data, they typically mean rather structured data like CSV, Excel, and all that. Again, the whole technology is really meant to be used to link all the different sources into one graph and also make a more detailed, let's say, structured approach around larger text fragments. So even if you have in an Oracle database a big, let's say, text field with many sentences frequently found in, let's say, health records, for instance, you can take out this unstructured part of the relational database and then translate that also in this graph structure to all the, let's say, entity extraction, and then use that highly structured representation of your relational data to do further analytics, ask questions if possible with a question answering machine then later on even.
Was that enough answer on your question, Will?
Will has said, okay, thanks.
Yes, yeah,
okay, yeah. Well, I have an additional question related to that. In your answer, it was especially getting the spoken text in videos by speech recognition, making it written text again, and then do all the things. Is there also a possibility for image recognition and combine those kind of things with it?
Yes, it's clearly spoken. We are working on it. Even some of my colleagues now, we have a lab inside our company. It's the Pool Party Labs, and 3 colleagues now have submitted a Pool Party Labs project in this area where it's about image recognition combined with knowledge graphs and what you can do with that. What you need really is a service firsthand which does tagging of your images. So there are several such services available. For instance, on Azure, you may find some services like that. And then next step, if you have the vector, the tagging or the vector, you could call it, of the image, you have to attach it to your knowledge graph. So if you find there, let's say, a cow, a mountain, and a tree, then you will attach that to your knowledge graph. And then with this richer context information from the knowledge graph, where you find out what a cow is, for instance, an animal, which lives somewhere in the Alps, maybe, you could later on ask a question like, where are all the images where you see a picture of the Alps, And if there's a mountain and a cow, then you can infer that's probably the right picture and so on. So obviously, again, what you do first is to do entity extraction, then put the found entities in a larger context, and then apply certain rules and ontologies and all that to make bigger sense out of the known facts. And by that, you can infer also the not so obvious and not so explicit metadata of a given object. Gartner is calling that active metadata. That somehow sounds interesting, I would say, because it's really somehow more useful, this kind of metadata. It's not just system metadata, like how big the picture is, or it has 4 megabytes. Okay, it's also interesting sometimes. But this kind of metadata, of course, helps us to make more, let's say, business-oriented, value-oriented activities with our knowledge assets we have in our organizations.
Okay, thank you. Before I continue, I'd say that some of the participants are leaving already, probably because of the time. Before more are leaving, I like to tell the people who are there that a link to your presentation will be published on our website. Moreover, it has been in the chat already, and also we made a registration of the whole session, and we will also provide a link to this registration on our website, so you can always look back at both the presentation, which was actually, as I saw, much longer than we have actually seen, and to re-listen to the whole story. Okay, are there any more questions right now?
One I've seen from Harry Wendell was asking what I'm looking at in the background. I understand it's this virtual background, you mean? This is graph views, as we call that. It's a visualization of a knowledge graph. You can play around with that online. I just posted the link in the chat. There are several different domains. In that case, I think I have the Harry Potter graph on. So you can play around and put concepts in focus and highlight the relations and all that, and send out the link to share it with someone else and all that. So that's just a little bit of a playground, because most people always expect to use graphs for visualization. This is a nice use case, but knowledge graphs are for sure not just for visualization, but rather for data integration and all that, what we've been talking here about. I also pasted the link to the cookbook now in the chat, so that you can easily find it, and from there you can download it for free if you're interested in more information around that. Yeah, so that's it from my side. By the way, is this video now recorded and will be on YouTube publicly available, or is it just for members of VOGIN?
Well, we can make it publicly available as to us. At any rate, we will publish the URL of it.
Yeah, that's great. I've never been on air, so that's the first time in my life I'm on air now.
Yeah, I don't think many people follow the stream on YouTube, but it's a very easy way to get a good registration. Actually, a better one than Zoom is providing it itself.
Super.
Okay, well, I also had one final question before really finishing. Why is question answering so tricky, as you mentioned at the end of your talk? Whereas, for instance, Google does already question answering. Is it just because those are easy subjects, and it has so much more information than there is in a local system? Or are there other reasons why it's tricky for a system like yours?
Okay, Google does a fake question answering. They use sentence compression, sentence compression algorithms which means they just extract snippets of billions of the text snippets they have and predict this text snippet may be the answer to this question. But in the background, they don't use the knowledge graph to do question answering. It's purely based on the sentence compression algorithm. And by that, of course, you sometimes get really stupid answers. Still, it works quite nicely, but again, it's not a technology which exploits the knowledge graph at all. It doesn't use any inferencing or whatsoever. So with the knowledge graph-based question answering, I think the problem is really that you have to bring together several capabilities. First of all, this intent recognition, where you translate the natural language question into a structured query. That's really tricky. And then you have also to predict, okay, which of the subgraph now contains the answer to that question. That's in that case what I've shown, the finding the right Sparkle query thing, and train that. And then, yes, I mean, many cases you do not have all the data in place, so you have to do a lot of data integration in the background, typically in enterprises. So typically, the one spreadsheet is not already good enough to give answers to a lot of questions. You need a second spreadsheet and maybe a document collection and a relational database and so on. So there's many different steps to produce such question answering machines for enterprises. I think it's the future. We will have more and more of such engines in place soon. But this is really, as I've said, really a problem you have to, you face a lot of different challenges. Eric, you're muted. We cannot hear you now.
Okay, sorry. Thank you very much, both for your answer and also for all the things you told us. We were very glad to have you here. Thanks a lot, and I thank the audience also for the questions which they had for you. Thank you very much, and well, I hope to meet you again.
Thank you very much. Thank you. Enjoy your day. Bye-bye.
Bye-bye. Bye-bye, everybody.
Bye-bye, everybody.
Bye-bye.